next video or after your talk is Laguna Beach cast plays real or fake game.
Sweet. Awesome. Hang on, we are going to start momentarily since I can get this all set up. 2:13. Aha, there we go. All right, so good morning to everyone. I hope this didn't render very well, but whatever. Okay, so let me make sure that this is on. Recording. Yes, it is. Okay. All right, hopefully folks can hear online. Martha or someone might be monitoring, just see if somebody asks.
Yeah, I'm monitoring.
Pregunta, super. All right, so I'll keep this pretty quick, but the plan is we're going to talk about SQLite. And if you haven't used SQLite before, it's a type of a database. And I just wanted to talk a little bit about why you might use it. And I apologize that this did not render very well, but I did actually set up a number of bullets here to talk about just sort of how, why you might want to use SQLite and what are the pros and cons. So you'll hear people talk about using access databases or Post GRS, SQL, MySQL. Those are all also really great. Here's a better rendered version. There we go. Those are also really great options, but they're really for different purposes. Those are typically what we would call a client server-based database. That's because it's sort of a central repository where people can access, multiple people can access up online, essentially, using accessing it via a network. Whereas SQLite is really very different. It's very much more for local, for just one person at a time, which makes it really portable, pretty fast, and really small size-wise. It's great. And it functions well. One of the other cool things I've started to play around with is it functions well with something called SpatialLite, which makes it possible to use GIS-based. You can add shapes into your SQLite database, and so then it becomes like a little spatial database. So you can include tables and data, but also your shape files, which is really cool. And so the other thing is it stores all the data locally in one single database. So you can easily zip that up and just send it off to somebody and they can open it up on their computer and all the same things are there, which is really nice. Again, some of the things that might be a drawback, depending on what you're after, you can really only have one user per database at a time. It's not really meant for sort of a place to house something that multiple users are accessing. I'll caveat that in a second. And then it's not meant to take work over it. It's not really meant to work over a network. So if you're accessing it remotely over a network, you can have some issues. But it is actually one thing that people are using it for pretty commonly is in websites. It's actually, it can house data really, really effectively for a website. Like if you wanted a user wanted to store data or query data from one of these SQLite databases, it's actually one of the things that's what it was written for, actually, is like a mobile database because it's so small. I think it got written for mobile phones originally. So Any questions on that? I just wanted to sort of, what is SQLite? And I'll show you how to set one up and how to put a few tables in it and query it, and then go from there. But pretty much what I've been using it for is like, I have a bunch of different tables and field data and different things, including spatial data. And so I've been able to build a little database, which is really nice because I can store and update it really quickly, and it all lives in one place. And I know that that's like my clean, happy place where I can put my data and it will stay there. And then if I ever need to sort of move it to another computer, I can easily take that whole database and pass it along, which is great. So it's really good for version control sort of stuff as well. Okay.
Ryan, is that for a particular project that you do that?
For my dissertation project, yeah. So like all my dissertation data sort of sits in a single SQLite database, and then I can pull from that pretty easily.
Can you pull from it? You can pull from it on any computer?
Yeah.
Just one user at a time.
One user at a time, so you can't, it sort of locks when you access it. So yeah, one user, it's not meant for like multiple, like if I can keep it on my Dropbox and still query it, but I haven't done this, but I'm assuming if two people are trying to do it at the same time, things might happen. But it seems to work pretty well as far as that goes. Like I can query from any computer to one database, yeah. Okay, so to start, I'm going to list, there's a couple different packages that you can use to actually access these, to create these and do these. dplyr and reader I'm going to use to basically sort of play around with the data. dbplyr is now a newer package that's part of the dplyr or tidyverse world, but it works well with pretty much most databases. SQLite is the primary one, sort of under everything, and then Magritter is for pipes, and DBI is another database. I'll show you two different ways to access these. So one is sort of in the dplyr world, and the other one is using this DBI syntax. They both work. It's kind of up to you. There's flexibility for both. One thing I will say, if you work with folks that have an Access database, you can bring Access, you can read an Access database into R as well, which is pretty awesome. I'm not going to show that today, but I just want you all to be aware of that. I figured that out like a few months ago, and I was like, oh my god, this is amazing. Yeah.
Is this posted online?
Yes, it is. Hang on. It is on a GitHub.
You're teaching SQLite demos.
Hang on. Yes. So here is this is where this lives. We can maybe post that to comment to the video or something. I don't know. Cool. Thank you. But it's on GitHub. I'll post the links and stuff to this later when I clean it up a little bit. I was doing this somewhat last minute since daylight savings time was a disaster for 2 children.
Like your tweet about that.
Right, yeah, thanks, yeah. That's basically, yeah. All right, so I'm gonna show this demo using the data carpentry ecology data set, which is this, they actually already have a portal database that they use, but I'm gonna show you how to make a new database, put some stuff in it, access that back out, and then we can pretty much leave it there and talk about it if you want. So to start, to create a new database, we're gonna load up all these packages, okay? And then what we're gonna do is essentially run this single command, this source SQLite. So I've wrapped this in here, which is a different package for purposes related to, let me actually just go to the code. So we can do this. Make this easier to see. And make it a little bigger. Okay, so first off, I'm gonna go ahead and delete this, so we'll make a new one. I'm gonna load our packages, that chunk there. Now I'm gonna create this database. Now one of the things this here package does is essentially just tells it what directory I'm in, so I've wrapped it in that so that when it knits, it makes it easier to deal with. So ignore that for now. But the main function is source SQLite, where you want to put it, what you want to name it, and then create equals true. If you already had a database and you just want to read it in, you would change that to create equals false, and then it's essentially just accessing your database. So let's run this. Could not find function here because I didn't load the here package. Here is a very handy package for those of you that work with R Markdown. Okay, there we go. So now you see I've created this database. There's nothing in it. Hopefully, there should be nothing in it. So source tables, src underscore tables, basically, is the function that we use to look for the tables. And there's nothing in there, so it gives me character equals 0 at the moment. Great, so we have a new database. Pretty simple. You can see it's here, it's named that with that SQLite extension. So the next thing we want to do is essentially add some of these data sets that I talked about. And I'm using these directly from a web link. And I think I've added that in the, yes, so they're all here. So let's go ahead and load these up. So surveys, there we go. I'm using read underscore CSV, which is part of the from the reader package. Okay, take a look at these, and you can see that we've got this data set's really big. So this is 35,000 observations, and it has a whole bunch of different variables, but it's pretty big. That's a pretty decent sized data set. Let's load species, same thing, and take a look at that with glimpse and 54. Notice that there's a couple, the nice thing is now we have species ID here, species ID here, so we could join these tables now. The other thing to think about is like, you can put as many tables in as you want. I think the size limitation on the SQLite database is like a terabyte. It's ginormous. So an Access database is limited to 2 gigabytes. Which is one of the pluses to using SQLite. It's space doesn't really matter. Not that you want to really be portably like copying a terabyte, database around, but you can put as much in there as you want. And then plots. So plots. So now we have plot ID and plot type. So we could join all these tables together into one big data frame and query it and do all kinds of different things, which is really nice. So let's add one other thing that I'm going to just make here. Let's add some XY data so that we can actually say where our plots are. And I'm totally arbitrarily just making this up. I'm making a plot ID column so I can join things to that. A longitude and a latitude using a just random uniform distribution. Okay, so let's take a look at that data set. Plots XY, so there we go. So now we have plot ID, got our longitude and latitude. And these are roughly centered around Yosemite, so for no particular reason. If you want to see here, let's make just for fun, because there's literally no visuals aside from this, so we'll do this. You have something to look at. Here's a quick map of where we just made these points, right? Okay, there you go. So there's all our let's see, topo map. There we go. So there's our plot IDs. So these are, each plot has its own XY point. Cool. All right. So now we have 4 tables, right? And an empty SQLite database. So the way we copy these in is the very complex copy underscore to command, where we basically give the database and the table name, so the object that's in our environment over here. So we have these tables, and essentially we add temporary equals false, which means we want to write it permanently to the database. Okay, so let's try this and see what happens. So there we go. Cool. And if we go, let's go look at our database. Now the size, watch the size change. And we'll make sure it's in there in a second. Okay, pretty small plots and our plots XY. Now let's remove these from our environment. So we're going to take these CSVs that we read in, and we're going to get rid of them. So now in our environment, we only have, actually let me remove .sf too. Okay, so now we just have our database connection here. This is our database. If I click on this, you're not going to see anything that's super useful necessarily. It's just saying that that's our SQLite database. But now we want to see how do these tables, do they work? So to do that, we use our source underscore tables again. This is from the dplyr, dbplyr package. Now, here we go. So now our database has plots, plots XY, surveys, and species. You'll notice it has a few other tables in here. SQLite underscore stat1, SQLite underscore stat4. Those are sort of indexing tables, so you don't need to worry about them, but it will default, when it adds these tables, it will make a few of these temporary sort of indexes. So if we want to check, and the other option to look at the other tables is this command, which is essentially taking our SQLite database, and then if we click on that, you'll notice there's something called con for connection. It's not listed in here. Oh, there it is, yeah. So this command comes from the DBI package, or this function. It does the same exact thing. It lists the tables in our database. Okay. One additional thing we can do, we can look at the dimensions of all the tables in our database. Say you get a database and you want to know not only what the tables are in here, but you actually want to know how big they are, like what that data might look like. We can use the per package, which Brandon gave a really great per overview we have up on the DRUG website, to essentially map or loop through this list of table names and give us, all I'm going to do is give the dimension. So I'm taking map, sourcing our tables, so it's essentially looping through this set of names, and then applying the dimension function to using this dbread table. So it's reading the table, giving me the dimension for each one, and then listing the names. So let's run this. Could not find function. Oh, I need to load the package. Per. Okay, there we go. So now let's take a look. If we remember when we looked, this was really big, so that looks right, great. These tables, again, are indexes, so there's nothing really in them. Species, plots ID, so we can take a look at our data really, really easily. So, and you could add anything you want here. You could say glimpse, you could say whatever it is, head, yeah.
Is the database, is it limited to table data types? Or can you put in other data types in there?
Like what sorts?
Like a raster or a model, or something.
I think you could put a model in there. Any tables, pretty much anything that is in a table format, it will accept. Rasters, I'm not sure. I think you can, because it's spatial. You need the SQLite extension, but that does work. Although it makes it really big sometimes if it's a big raster. But yeah,
But you keep all your tables in one spot and then your spatial data separately, maybe.
It depends. I actually have one that has both my like any tables associated, like data that's associated with that spatial data. I keep all in one thing, but I don't work too much with raster data. So for that, I might actually use a different, like keep them separate, just because querying it might be different. But I think you can. It's pretty flexible. You can put quite an array of data in there, but I do think it has to be some square or rectangular data of some sort, typically. Cool. If we want to look at a single table, so say we know we only want to look at one table, we can do basically, I'm just pulling this function out here, same thing, take a look, there we go. We're saying we want to look at the surveys. It's 35,549 rows by 9 columns. And if we want to see the first few rows, we can use a pipe to do that. We're going to use the table command, the database, the table name, and then pipe that to head. So this is another way. The other cool, so this is really fast. And one of the reasons why databases and SQLite in particular is really great is it's actually, notice it says a lazy query here. it's not actually pulling that data onto your computer when it's querying that or into your R. It's actually just sort of like quickly looking in the database, giving you this back, but not actually writing it or putting it in your memory. So it can be really fast to access really big tables, which is why it's a really great framework for doing sort of data analysis and or storing data. Okay, and so I talk about this here. So we accessed the database and determined the dimensions of each table, but we didn't actually bring a copy of those tables into our environment, which makes it very flexible and fast. But say we actually want to take that data in and do some stuff with it. To do that, we essentially use a command called collect. And so what we're going to do is we're going to write an object called plots from the plots table. So we're essentially just copying the plots table back to our environment using this. There we go. Now we have plots in our environment. Let's do the same thing for plots XY. Great. Okay, so we have two new tables. We've pulled them back out of our database, back in our environment. You can plot them, join them, whatever you would like to do. We could join them. We could, add a new row. Let's pretend that we want to append a record. So you can write entirely new tables. We've shown how. Like say you had a new data table, you would use that copy to command that we used up here. Where is it? Here we go. So that's to write an entirely new table. But say you want to just append a few new records. You've gotten some update to a given table. Well, to do that, we can check. Let's check our tables again. Great. There's plots. So plots has 24 rows at the moment. But let's say we found another site. We forgot to add a site, and we want to go ahead and add that. So let's make some data, new data. So I'm going to just basically make plot ID 25 and climate plot. Okay, so now I have in my environment this new bit of data called new plot dat, one observation. Okay, so there's two options to write this, to append this to our database. First off, we're going to use this DBI option where we're connecting to our database. We're looking for the plots table, and then the value is this is the data we're appending. And notice append equals true. So if I take append equals true off, it would actually overwrite the table completely. And in this case, I want to just append this record. So let's try this. Okay, and then let's double check. Again, let's take a look. I'm going to access that same table, collect it, remember? So bring it to my computer, and then print. There should be 25 records because the original one was 24. So assuming we appended this successfully, we should have 25. There we go, we do, there's 25 and it says climate plot, which is the one we added. Done, we've appended a new record. Now, keep in mind if you have a really complex table, you would probably be reading this in from some other thing. You wouldn't be like manually making your data frame, right? But that's pretty easy. So you can update records. Keep in mind this will append whatever. It's like binding just new rows to your data frame. So if you are duplicating things, it's not going to recognize that. So it's easy to actually end up. You could potentially screw up your data that way if you're not careful, but you can always filter it out later and take care of that. But this is to append to a data. You can do the same thing using this insert into. So this was DB write table. This is insert into, and it's the same sort of structure: the table, the value, and then I'm not going to run it, but essentially we should end up with you're adding one additional. Well, let's just do it. We'll insert the same thing using a different function. Let's take a look. Now we see we've appended the same record again, 26 rows. Okay, and what's that? 26. Run that. Yep, 26 by 2. Okay, cool. Well, let's delete that table now that we've screwed it up. Let's drop one. So again, source tables is to check what tables we have. Okay. To drop a table completely from our database, we use the connection to the database and then db drop table and then what the table name is. Okay, so it's going to give me a list basically saying one table has been dropped. Let's go back and look at our table names. There we go. So plots is no longer in our database. Pretty easy. So we can now easily recollect that data and re-add it. So I'm going to read again the data in from this web link using read_CSV. Copy that back into our data frame, or our database, sorry, using the copy to and temporary equals false, so that it's writing it to the database. Okay, and then source that. There we go. Plots is back. And let's make sure that what size is 24. So now we're back to our original data set that we didn't append anything to. And we can check the size using the per function again, where we loop through essentially all the table names. Just if we want to make sure everything is the size we originally of the original data set. Yep, looks right. Cool. All right. And then this is one other option. So let's say now we have this data set. If you want to connect to your data after the fact, here's another way to do it. So now we have a database. Let's go ahead and I'm going to restart my R so we have nothing in our environment now, other than some random functions, but there's nothing in there. We have this nice database. So let's use this as our path, okay? And then that out. Now I'm going to connect. So I've basically given it the path to the database. I'm going to connect to that database. SQLite. This works for MySQL or a bunch of other databases too. It's really great. So this is a really flexible and powerful set of commands. So we can grab basically a connection to that. Oh, I need to load the packages. Sorry. Let's go here. Okay. Try that again. So load our path, connect to our database, right? And then let's list the tables and see what's there. There we go. It's all there. If we want to just look at the fields, maybe we want to see what kind of data is in there. We can use this list fields, and that'll list these particular fields, which is kind of cool. And then if we want to add that data, collect it, right? This is the other option. You've seen how to collect the table. We can use this other thing called DB read table. There we go. Now we've brought that into our environment, and we can work with it. So let's do the same. Let's say we want to read the surveys, right? What was the other? Yeah, surveys. Let's do that. DB read table, the connection, and surveys is the table name. There we go. Now I've got surveys. Okay, that is it. Oh, one thing I haven't mentioned, it is typically a good habit to close your connection after you've been accessing a database. Because right now we have this sort of open connection that we've made to this database. And so what's the command? DB close. Disconnect. So DB disconnect and DB con, I believe. There we go. So now we've closed that connection. Sometimes if you forget to do that, you might get a warning later on, like, you should close your connection, something like that. But that's particularly if you're accessing not necessarily SQLite, but other types of databases. When you make that sort of connection, you want to close it when you're done, because that sort of can cause issues down the line if you keep that open. So that's all I've got. If you have any questions or comments, I didn't have time to show the spatial light, but that requires a little bit more. You need to do some command line to essentially, you can either do two options to do a spatial light, which is the ability to write shape files or read shape files. So to do that, you need to either create it in QGIS or ArcGIS. Both have the option to make a spatial SQLite database, or you can use command line, and essentially, I've been able to do it on a Mac on the terminal without any problem. Create a new SQLite database, and then you can write your shape files right into it. And then once you have it, then it's easy. You can use all these same commands to write new tables to it, right, or pull them down. But the creation of it is sort of one extra step where you have to create it independently of the way we've done it. It won't work if you do it that way. That's all I've got. All right. Any questions, comments?
Say I made this, I put all my data in it. How would I like give this to my, like, how would I share this with my lab mate? Would I just send them
Just-
the link to the SQLite portal?
You literally would just send that file. Yeah. So we're, let's open, find this file. Here we go. So it's in my data. There we go. I could literally just email that to anybody or send a link to it and they would have the full database and they could open it. So there are a few really cool packages or pieces of software that, so for example, there's this thing called our SQLite Studio, which I've been using on and off just to take a look at your data. And it's actually pretty handy. So say somebody wants to open this up and look at it. So here's a couple different databases. I've got, let's go ahead and open that one we just made. Where did I put it?
Is this like a program for people?
This is an open source program, I believe, that runs across platform. So you could download this SQLite Studio. There's a few that work really well for this, and you can certainly use this to create your database and do the same thing we've done. But just to double check, or if somebody else doesn't use R, they could use a package like this. Yep. Yep. So this is a kind of a nice. What the heck is it? Oh, there it is. So data. There we go. Open. Okay. All right. So now notice we have this new portal database. If I click on that, it shows me the tables. And then let's say I want to see this table. It's columns, index, triggers. If I go over here and I click on data, it actually shows me all the data, right? Which is kind of nice. And you'll see a bunch of buttons. You can add rows, delete them, modify them, and we'll save that to your database. So this is another way to access things, sort of if you're working with somebody who doesn't work with R, there's packages or programs like this that do this. The downside to this is you could be modifying your database and have no record of what buttons you click. But as far as viewing what you've got, it's actually pretty handy and flexible and works really well, even with big data sets. You can filter it and do other things like that. So this is SQLite Studio, and there's another one that I've used that works really well cross-platform, which I forget. If you sort of Google like open source SQLite software, there's 2 or 3 that should pop up. Cool. All right. Unless there's anything else, I'm gonna sign off on here.
So you would say the main benefit of using like an SQLite database is sort of just having all of your data in one easy file?
One place. And it's a clean, I mean, it's a way to think about if you have a bunch of CSVs or tables kind of all over the place. You could certainly keep them in that format, but as far as having it in one single place that that's like your clean data set or your raw data set, you could even have a raw SQLite and then your sort of model or clean version, like kind of up to you, but just another tool that you can have to sort of keep things tidy, which is nice. Cool. Thanks, y'all.